today we have Giovanna Merli, who's an expert in RDS. She's used RDS for essential network samples around the country, and she's currently a professor at public policy here and a member of one of the leaders of the Duke University Population. The university is now part of the title, right? The Duke University Population Research Center and Institute, and as well as DNAC. And so thanks very much, Giovanna, for taking this on.
Yes, thank you. Well, lots of what I'm presenting today, it is really the fruit of the collaboration between myself and Jim, and also Jeff Smith has been participating in this collaboration at some point, and Jake Fisher, whom you have heard yesterday. So there are all these wonderful collaborators that have really made this project much better. I also work a lot with Ashton Verderi at Penn State and with Ted Mao at UNC. So this is, a wonderful group of people who have really contributed to the evaluation of the performance of respondent-driven sampling. And today I'm going to talk mostly about respondent-driven sampling, and in particular about our evaluation of it in the context of a population of an empirical population of female sex workers in China. I do a lot of work. Most of my data collection work takes place in China, and more recently we have moved to the US. I feel I'm older. I don't want to travel as much as I used to, and so the next project will be here in the Raleigh-Durham area on Chinese immigrants, to this area. So that's the. But if time permits, I will also talk about network sampling with memory, which is another network sampling approach. It's much superior to RDS. It's harder to implement. I'm a big fan of it, and so I want to introduce that too. And the network sampling with memory actually was developed by Ted Mao. Many of you know him through CPC, and Ashton Verderi, who was also a CPC until he became an assistant professor at Penn State. So I fell upon RDS when I was planning a survey of sexual behaviors and sexual networks in Shanghai. I was interested in evaluating the potential for the spread of HIV in China, and so we had plans for an egocentric network survey of the general population in Shanghai, but also we had plans for recruiting a sample of female sex workers in Shanghai, given that female sex workers are the driver, sort of some crucial drivers of the spread of HIV and other sexually transmitted disease in the Chinese context. And so I fell upon respondent-driven sampling, in an article in Sociological Methodology, the Salganic and Heckathorn. I am a demographer, I should say. So for me, it is essential that when I recruit a sample, I want to be sure that the sample is representative of the underlying population. Now, female sex workers are a hidden population, right? And so what do we mean by, these are the funding. I always have to acknowledge, the various sources of funding. So they are a hidden population. I mean, they are a hidden population as much as other vulnerable population groups are hidden. What do I mean by hidden? It means that there is no sampling frame from which to draw a sample with known probability of selection for each sample unit. The thing is that we are very interested in this population because, like in the case of China, but also in many other settings, they often drive the spread of disease. We're also interested in discerning impacts on the general population health dynamics, and also to identify gaps in HIV prevention. And so we need to have accurate and precise description of this population, including its most hard-to-reach segments. Now, it is a challenge to collect, to recruit a representative sample, a good sample from such population. Because of the absence of the sampling frame, as I mentioned, it's very hard to identify members, often because of stigma stigmatized behaviors. Members don't want to be identified for lack of trust of the researchers. And also, this population are rare, right? So, say if we conducted a study based on a conventional representative sample of the general population, we would need to do a lot of screening interviews in order to gather an analytical sample of this rare population. For example, I did a survey in Shanghai of the general population before I even did the female sex worker one, and we got it's also a question of accurate reporting of behaviors, but we got sort of a handful of self-identified female sex workers. Obviously, that handful, a few sex workers would not have allowed us to study, the characteristics of this population. Most of the many approaches that are used to sample hard-to-reach and vulnerable populations often lack basis for inferring representation. Now, respondent-driven sampling has a wonderful promise or a wonderful claim, and it claims to produce representative estimates of characteristics of hidden population, and its claims are based on a probability inferential structure. There is a lot of interest in respondent-driven sampling. NIH has funded tons, including ours, but it has funded tons of studies on respondent-driven sampling. These statistics were drawn by Ashton on just looking at the sort of NIH reporter, 400 plus studies, over 185 million spent on RDS, being in the title or in the contents of the talk. So clearly, RDS, by the way, was developed by Doug Hackathorn at Cornell, in collaboration with two of his students who have since, Salganic is now at Princeton, and Waltz, where is Waltz? I don't know. But in any case, so these are sort of the three, sort of the Bible of RDS, like these references here, and I can send, I think I've assigned one today, but if you're interested, I can provide you with the full references. In any case, they're easy, to locate. So how does RDS work? How many of you are familiar with RDS or have used RDS? So a good number, right? So that's but I will, repeat it briefly for people who are less familiar with it. It is primarily used to estimate binary population proportion, population proportion of binary nodal covariate infectious status. That's a big one, of course, when it comes to this type of population, gender, tier of sex work, that is the variable that we have focused in our evaluation. It leverages social networks of respondents to recruit other respondents. This is a linked tracing design. It is grounded in a peer recruitment, which is very nice because it reduces concerns of confidentiality. You're asking respondents to invite and recruit and invite other respondents, which means that the researcher doesn't have much control on how the respondents are making their recruitments. Okay, this is an advantage, to reach these hard-to-reach populations, but it is also, as we will see, a disadvantage, for inferring representation from the samples. Yes.
With regard to seed participants and peer recruitment, do you find that it's more effective to do peer recruitment based off of demographic characteristics versus behavioral ones? So, for example, I'm thinking of, let's say I'm looking for Latinas who have not had mammograms in the last 2 years. I think my personal experience has been they're able to identify other Latinas, but that behavioral response is harder.
They have to be observable characteristics,
Yes.
right? So you are defining, again here, you're defining the boundary of the population. In the case of female sex workers, we specified the number of people, the people who have had sex for money in the past month.
So there is behavior that's salient to their identity.
Exactly, that is salient to the identity, but it is also observable. That is sort of if. So you start with a number of seed participants, a small number of seed participants, usually selected by convenience. I mean, you have to start somewhere. You're providing 2 or 3 coupons. 2 is better than 3, for reasons that I will mention later if you're interested. But you are asking them to recruit 2 or 3 participants each, and so they will go out, sort of into their networks and recruit, through multiple waves. These participants, you're using incentives both for primary recruitment and for primary participation in the survey, and also for successful recruitment. I mean, this is sort of a method that works well, also because it is grounded in meaningful, though not coercive, incentives. No one participates more than once, so this is a without replacement type of sampling, and the process continues until the desired sample is reached. Yeah.
Okay, question. I've read about it mostly, but never participated in it. What are these coupons?
Okay. So coupons are, I don't have an example here, but usually, they're coupons, they're key because, they have a code that allows you to link the recruiter to the recruitee, right? So there are pieces of, we had pieces of papers, because we were conducting a face-to-face interview rather than sort of a web-based interview, for example. And so, there are coupons with the name of the project, with a code that allows, that allows to link to the recruiter, sort of the recruitee to the recruiter. So these are they're pieces of papers. Plastified, depending on how pretty you want to, sort of draw them. Yes. Well, you do, for RDS, you have to do a lot of formative research, right? You're getting ready. I'm not talking about sort of that part, but certainly, you have to calibrate, the incentive to the population. You want to be sure that the population members are responsive to these incentives, and also at the same time, you want, to make sure that they are not coercive. Otherwise, the IRB will shut down the project, right? In our case, for female sex workers, we had, for female sex workers in Shanghai, we had monetary incentives that were enough to cover their lost time, while they were participating in the survey, but we also were offering free consultation surrounding reproductive health. It was a participation with the local hospital, and that was highly, highly valued by these women. Yes. So that's, it really produced a very high participation rate, very low response rate. There are ways also to assess response rates, in RDS. Well, let me just tell you how it works, and then I'll mention, remind me, sort of about response rates. So, you start with a hidden population with 2 attributes, red and blue. It could be gender. It could be, the tier of sex work, where they're working. It could, so you start with 1 seed. In this case, I just have 1 seed, and you proceed. You ask seeds to recruit each, in this case, 3 people. And you proceed, in this fashion until your final, your desired sample size is of the hidden population is recruited. Now, when they're coming, yes.
A seed, are they like very specific people, or are they the people who have been already identified as participants?
Right.
Or they
The seeds
like
are people that are member of the population. They have to be highly motivated, right? Because they have to motivate their peer recruitments, and motivate their peer recruitments, recruits to motivate other recruits, right? So they have to be trusted. They have to trust you. You have to trust them, right? So that is usually based. The selection of seeds is usually based on a lot of formative work. Now, seeds are a convenient sample, right? They're not drawn at random from the hidden population. You usually seek to stratify seeds based on your knowledge. You have to have a lot of prior knowledge of this population, right? You have to stratify them based on some characteristics of interest, especially if you suspect that cross recruitment between groups in the population may be difficult, right? So there is another challenge, right, of course, of RDS. So clearly, it's very important, to select good seeds. I mean, here I started with one, but usually, depending on the sample size, most of the RDS samples, in studies that I've seen, are about 500 to 600, and let's say 5 to 6 seeds. I mean, that's sort of the ratio that I've seen. Yes.
So as far as, are you using standard sample estimation procedures?
Hold on, I'll talk about it a lot.
How does this differ from the snowball?
Right, the snowball, first of all, you're controlling the number of recruits that people are bringing to the study, right? You're only giving 2 or 3 coupons, right? You're asking the members of the population to recruit their members. In the case of the snowball, you're usually asking how many people can you give me their addresses and names, and you go and find them, right? There is a large number. I mean, there is no limit on the number of people that you can recruit in snowballs, right? So that the characteristics of the sample will be very much skewed towards the characteristics of the most popular individuals, right? This is a major problem of snowball. In this way, with the coupon rationing, right, you are trying, to limit, this major problem of snowball. I had another question, or? All right, so this is with 5 seeds. This is a typical, so it's about 560 members of the female sex worker population that I'll describe in a moment. So note 2 things. First thing is that you only know who recruits whom. Okay? You have 5 seeds, 5 chains. You know who recruits whom, and you know the attributes of the recruiters and their recruits. That's all you know, right? So you don't know in the grid for any of these sample members, right? You don't continue sampling until the population is saturated. Now, if you knew in the grid, right, of each sample member, and you continue sampling until the population is saturated, then you could construct the sampling. I mean, you could calculate the sampling probabilities and construct the sampling weights, right? So, in the case of RDS, you have to make a lot of assumptions about these things, as we will see. So, so the sample inclusion probabilities for an RDS sample are not known, right? Because we don't have this other information. Researchers have limited control over the sampling process. Now, is the sampling process random, right? We don't know. We are instructing participants to randomly select their, 2 of their out of their network members, but do they select at random, right? And what does it mean, sort of at random? And also the seed respondents are not chosen at random, so there is concern that the characteristics of the initial of the seeds, will somehow influence, sort of the composition of the sample. Okay? So these are problems with the estimation in link tracing design. So RDS provides a solution, which is very effective, right? Based on a set of assumptions, it uses degree, respondent's degree, as an approximation to the inclusion probabilities. And so if it is approximated correctly, then the inverse of degree is the weight that you use to downweight the characteristics of the most popular individuals. This assumption is called the sampling with probability proportional to degree assumption, right? And this is a major assumption in RDS. And now, yeah?
Maybe I just didn't follow it correctly, but wouldn't your degree be a function of where you are in the chain? So, define the seed node, and
You're asking people to report on on the number of people they know, and that is the degree.
Okay, I'm
Okay?
tracking now.
Yeah, sorry, I did not mention that. Right. And that is the degree. It's a self-reported degree, right?
Okay.
Okay. So that's the, sorry, that's, I mean, I'm not, I should say, I've learned a bit about networks from Jim and from all these other collaborators, like for the most, so, I mean, this is a demographer using networks, which is, a very nice combination, and, this is clearly sort of also challenging to think about sort of the parallels, right, between networks and populations, right? I mean, that's, yeah, and so that's why, I'm starting from sampling, because, this is, sort of the, the sample recruited in this fashion, really represents the underlying population. So the, so this SPPD assumption underlies most of the RDS estimators. If you look at the literature, there are 7 or 8 RDS estimators. Most of them are small adjustments to the previous conventional ones. I should say that the conventional estimators, the ones that Heckathorn and his former students worked on, are the RDS2 Volts and Heckathorn estimator and the RDS1 Salganic Heckathorn. These are sort of the 2 conventional RDS estimator. How many of you have used RDSat? Right, that's the software that Heckathorn has put out to generate proportional estimates from RDS samples. RDSat is implementing this estimator, right? And this estimator, underlying this estimator, there is the SPPD assumption, and they are estimating the proportional recruitments from group A to group B. These are always estimators for sort of binary values. Okay? The Volz-Heckathorn estimator also works for continuous variables. This is the one that is most easily connectable to a traditional sampling estimator, which is the wait, I'm missing, for some reason I'm missing a well, it may come later, I hope so, because I thought that I had another slide here. It is sort of most easily linkable to survey statistics with the Horvitz-Thompson estimator. So what they do, what the Volz-Heckathorn estimator does, it replaces the inclusion probability in the Horvitz-Thompson estimator with the degree. I mean, that's as simple as that. And I thought I had the slide, but anyway, yeah, I want to talk to you very quickly about this LEN estimator. This is LU, 2013 social networks. It's very close to the Salganic Heckathorn estimator, but rather than using the estimated proportion of recruitments from group A to group B, it uses the proportion of network ties from group A to group B. So it uses ego network data, right? And we'll see how important this is, to address issues of, the violation of the preferential recruitment assumptions. But we'll see it in a moment. Okay, so there have been a lot of evaluations of RDS, including ours. I should say I'm very proud of ours. Why? Well, of course, because we have all participated in it, and it has been a very successful collaboration. But also, I'm very proud because many of these estimations rely either on synthetic networks or on ideal recruitment chains, right? On simulated recruitment chains. Now, we ground both the underlying network and the recruitment chains, the RDS recruitment chains that we are running on the networks, on real empirical data. And the data are coming from this study of, in the context of female sex work in China. I realized that I'm missing a very key slide that I mentioned, that talked about the assumptions of the method. So let me tell you in words, intuitively. The major assumption of RDS that grounds this SPPD assumption is that according to which recruitment is random. Recruitment of the next wave of respondents is random. Respondents recruit randomly from among their network members. Okay, so that's a very key assumption. It's called non-preferential recruitment. Okay, so that is the key, the most crucial assumption. It turns out that, as you would expect, this assumption is easily violated in practice, right? So that there are many other assumptions about the structure of the networks underlying this sample network, the structure which we don't know, we don't observe, right? But they're not as crucial as the non-preferential recruitment assumption. Any questions? Yes.
I guess with regard to random, what characteristic? Like when you're asking people to nominate at random.
Right.
Are you giving them any-
non-preferentially meaning, usually the instructions that RDS provides say, get me different people, different type of people. That is sort of their, their way of sort of implementing. Turns out that there are preferential recruitment variables, that are, correlated, with characteristics of interest. In our example here of sex work is sort of the main one, right? Because it's correlated to so many characteristics of epidemiological relevance, right? But there are often, so we want to identify, of course, what is the offending variable, right? What is the variable upon which preferential recruitment is actually operating. But in general, the instructions are get me, sort of different type of people, and they should not be your closest friends, so that because the closest friends are more likely to be like yourselves. So the idea is, that the composition of the characteristics of your recruited authors should not be different from the composition of the characteristics of your network. That is sort of should not be part from that composition. It is, an operational definition of non-preferential recruitment.
The instinct behind it is that what you're trying to do is a random walk through the network.
Right.
And where the only things driving that random walk are the relative differences in sizes of degree. If that's true, then you can weight by the size of degree, and you can recover a valid estimate of probability. If you're picking on something else, you're not really doing a random walk. And so if you're not really doing a random walk, these estimates are going to be wrong.
And it
That's
is-
the intuition.
And it is my missing slide.
Yeah.
Because I talked about the random walk, and I'm sorry, I don't know why, the slides, maybe I wanted Jim to explain it,
So,
Yes.
did you ask them to name other sex workers?
Yes, okay, so,
And then they might be work under the same model, and then that would be not
Same
random.
money. Right, it would be, okay, so let me talk a little bit about our, our study. So we used the data that ground our evaluation are data from two concurrent surveys of female sex workers in Guangxi province, Yunzhou. Familiar with that, Yunzhou City? Okay. These are two surveys, one conducted with RDS and the other one conducted with PLACE. Now, some of you from UNC, will know PLACE. PLACE is a very good venue-based sampling approach for highly sexually active individuals, right? It was developed by Sharon Weir. This original data collection was a collaboration with Sharon Weir at UNC CPC. So the RDS study and the PLACE study. Now the PLACE, you have a frame of venues. So you have to list all of the venues in the cities, and then you recruit probabilistically with proportional to size of venues, from those venues. Now, if the population is only venue-based, then it really provides a pretty good coverage of the population. So we thought that the PLACE provided a decent coverage of the population. These are, it provided also the parameters for the simulations of the networks that Jeff, has been helping with. This is rare to have two concurrent surveys in the same population. The definition that you were asking about, the definition of the population, women who reside in Ujo who exchange sex for money in the last 4 weeks, was the same across the two samples. So now your question about the mummies. It depends, it could infuse, strong homophilia, right? It could infuse, in the selection. We don't know how these people are, how these respondents are recruiting. The problem with RES, and certainly a problem that we have experienced, in our data collection, is that often the chain gets stuck in some corners of the network. So in the case, sort of in a venue-based population, it gets stuck in large karaoke bars, right? I mean, it's easy, to find your recruitees from among your colleagues. So, there are all of these dynamics that are, in fact, that are, complicating, right? That are violating, the assumptions about yes. So, again, because I want also to highlight all the work, the good work that several people here, this is produced by Jeff. No, sorry, by Jake. Sorry. By Jake Fisher. So this is a very nice representation of our sample, of our 6 chains. The size of the nodes is proportional to the degree, of respondents. Turns out that respondents in karaoke bars had the largest degree, of course, right? Karaoke bars are really large. There are different tiers of sex work. Most of our evaluation was based on a comparison of the high tier with the middle and low tier, right? There is also, in terms of, this is one that Jeff produced, the social mixing by tier. You see that there is some degree, very low degree of social mixing between adjacent tiers, okay? But most of it is, quite homophilous, right? Low tiers, no, are more likely to recruit, and no, low tiers, and so on and so forth.
Do the seeds correspond to the major categories?
Yes,
Okay.
they were stratified in this way. And you do, I mean, like the chains do cross across tiers, right? I mean, there is some crossing across tier, based on that. It's not. No, so Jeff should talk about this. This is an example. He said, I have an example of using urban models to simulate networks. So you may want to tell them quickly how we did that.
So in 30 seconds.
30 seconds.
So I mean, the basic idea was to basically take the information from the respondents that they something about the ego networks that they interacted with. Basically use that information, which we had. So we talked about a little bit about what type of information you can get from ego network data. We basically about the degree. We knew something about, in this case, the tier of people they interact with. I think we also knew essentially how far. So like physical distance. So we had
Physical distance.
Of, how far? How long would it take you to walk? In order to find people. And so the idea was to take this information about the ego as well as the authors and summarize that information and then take those inputs as basically the way to generate full networks that were consistent with that information. And basically, it's a little more complicated. We had to sort of see the complicated population in the actual realistic geographic space. But the basic idea is that you can use these models that we just talked about as a way of simulating or generating networks based on effectively ego network data, which is a very useful way for combining RDS and ego network data with models we just chatted about.
Right, and this is really Jeff's piece here, right? So we grounded, the underlying, the simulation of the underlying social network in both place and RDS data, right? Which is quite unique, based on all of the evaluations, that we have preceding evaluations, and this is the seeded population. This is an RDS superimposed, RDS sample superimposed on it, and this is the simulated social network. And so then next, we simulated a large number of chains over this underlying network. Now remember, this time we know the underlying network, right? This is, usually you cannot see the underlying network when you're producing an RDS sample, which means that we know what the true mean, mean of the characteristic of interest, can be. And so then we can compare our proportion estimates from the RDS estimator with the true mean based on the characteristics of the underlying sample. And so we're doing this, we are running, we are simulating several scenarios. Now we are particularly interested in the recruitment patterns, right? So we want to look at, compare, the characteristics of samples recruited according to the observed recruitment patterns in RDS and the characteristics of samples recruited according to the assumptions of random recruitments, right? So we call it sort of RAN. We are also testing the seeds. Turns out, seeds, whether they are selected at random or, by convenience, they don't make much of a difference, to the estimate. Most of the difference are here between the simulated chains according to the observed recruitment patterns and the ideal chains according to RDS assumptions. This is a way, to test the sampling proportional to the SPPD assumption. You would expect if the assumptions hold, in an ideal random recruitment patterns, you would expect the relationship between the probability of being sampled and degree, to be linear, as it in fact is, under this ideal scenario. Under the observed, of the scenario consistent with the observed recruitment patterns, we see that the blue ones, these are middle tier, over-recruit from their networks in a manner that deviates from the non-preferential recruitment assumption. So there is a lot of preferential recruitment, especially by the middle and low tier sex workers. Yes.
Is there a way to catch the final sample size against the two methodologies? Is there a big difference?
The two sample sizes you're talking about, the place and the RDS. Well, RDS, is 583, place is 161. Now, there is a big difference, and I should say that the advantage of RDS is we got high response rates because the recruitment is done by peers, right? In place, recruitment was done by interviewers, so there was a lot of refusal. There were a lot of refusals. We then compared, we did several things. We concluded that even though the place sample was small, it was pretty representative of the population because we had RDS to compare it with. We did a series of analysis surrounding that question. So we're pretty confident. But in general, there is a big advantage to RDS because the peer recruitment. So this is a feature of RDS which complicates our lives in terms of the ability of RDS to produce a representative sample, but at the same time, it is a major advantage, to ensure high response rates. Okay, so we don't want to lose that feature, and the reason I'm telling you that is because we're doing something less in a moment. Okay, so this is the distribution of the Boltz-Heckathorn estimator, which is the estimates from the Boltz-Heckathorn estimator. Across seeding and recruitment scenarios, and you see the real world scenario, which is the one consistent with the observed recruitment patterns, is highly biased, while the ideal world, the variance is high, but the bias is low. Okay. Now variance is a problem, right? The bias is one. Biased estimates, but these estimates have tons of variability, and there is a major problem with RDS. The design effects are really high. What are design effects? Large design effects implying that much larger sample sizes than the typical RDS ones would be required to reach a level of precision that is currently assumed from RDS samples. So a sample of 500, with you would need, a sample 20 times bigger to get the same precision as in a simple random sample. So this is a problem with RDS. Large variance and large bias of the estimates. Note also that CDC recommends RDS sample size in the hundreds for public health surveillance, and it does use RDS to monitor populations at risk of HIV. The differences that you observe will never be real, right? I mean, the precision of the estimates from time to time, won't be, comparable. That is a major problem, with RDS. You will not know whether the difference you observe is real or not. All right, so we then using sort of the same approach, with the same samples of referral of RDS chains, we compared the Bode-Heckathon estimator, the naive mean, and the Stagganic Heckathon estimator with the LEN. Now remember, LEN is the linked ego network estimator, the one by Lou, who's using, who estimates the proportion, the composition, the cross-recruitment, using the composition of the networks rather than the composition of the actual recruitments, right? So you need to have data on on ego network data, which we collected, in our study. So we could actually implement the Lou estimator, and the Lou estimator does very well. Okay, it does really well. Problem is, you can only collect information on variables that are observable, right? Now, if the observable variable is the biasing variable, then you are you're good. In our case, the sex work is the biasing variable. It is observable. We collected information on compositions by sex work, composition of networks, and so we could implement the LEN estimator. Now, as I mentioned, RDS has a very unique feature, which is the peer recruitment. We don't want to sacrifice that, right? We know that that gets us samples, right? Sort of sizable samples. They may not be analytical samples, but they are certainly good, sort of diverse sample of the population. So what can be done to improve the performance of RDS estimates while retaining this method's desirable peer-driven sample recruitment properties? So we modified RDS data collection process. Then we apply, we modify it by telling participants to recruit people different from themselves, with different attributes, right? So this is called the IPRDS, inverse preferential RDS. The inspiration to implement this small data collection modification comes from a study that I digged out in the Journal of Computer Science by Nesterto and Blitzstein, where, with simulations, they were showing that these inverse preferential functions was producing, much better, much higher performing estimates of population proportion. So we tried the same, in our data, and we ended up. So this is like the type of inverse preferential recruitment patterns, right? That we are implementing. These are two different attributes. So you are asking, we did not test it empirically, but we are asking people to recruit people with different attributes from their own. And then we apply this antithetic variate mean estimator. So the combination of this IPRDS data collection protocol with the antithetic variate mean estimator provides much better performance in the IPRDS estimator. So this is these are different scenarios that range from no preferential recruitment to extreme preferential recruitment. You compare it with the naive mean or the Vaults hackathon estimator, and you see that the IPRDS with the anti-variant estimation performs so much better, right? So this is where we are so far. This is work in progress. I mean, we have not, we've tested it in another network that is the Project 90, and it works similarly well on gender, right? So, the key is to identify the main biasing, recruitment biasing characteristics, and instruct respondents to recruit inverse preferentially on that characteristics. The focal variable does not need to be the same as the biasing variable. We've tested it with different focal variables, and it does produce much better estimates, much better performance estimates. So this is an interesting innovation that we need to learn much more about it. So far, we are really at the stage of trying it out on different networks, and it produces high performing estimates. So it is a simple change to the RDS protocol. It again requires a lot of knowledge about the population and about how the population is likely to recruit from among its network members. But it needs to be field tested. So if any of you has interest, is about to go into the field with an RDS study and would like to add this simple module, please come and talk to me. All right, so I don't have time to talk about network sampling with memory. All right, well then, just let me tell you one thing about network sampling with memory, because I'm a big fan of network sampling with memory. It does a lot of the things that RDS does not do. It does a lot of the difficult things that RDS does not do. It collects network data. It tries to trace the underlying, to map the underlying networks that RDS assumes is of some structural fashion, but does not observe. It directs the recruitment process, so there is much more involvement by investigators in directing the recruitment process, especially towards areas of the networks that in RDS might remain unexplored, which is a major source of high variance estimates. So it does a lot of these nice things. It's much more time consuming and it's harder to implement. I'm a huge fan of it. Many of you who are interested in this at CDC should go and talk to Ted Mao about it, because it's a brilliant idea. It's labor intensive and more costly. But I'm sorry, later on, if you're interested, I can talk to you about NSM. Thank you.
Thank you.